Well, hi, good morning. Thanks so much for joining me here in my shop. I'm going to go to the next stage with this radio, which is dealing with capacitors that are paper capacitors that are associated with the IF circuits. And that has forced me to finally analyze the circuit diagram down in this area with these voltage drop, voltage divider resistor sets here. So I'm going to focus on this first and try to figure out how this was supposed to work, and before I start fooling around up in here, because there are capacitors now that are kind of running into this stuff a little bit, and it's just a good time now to hunker down and figure out how that works. So let's take a look at the circuit diagram together here on the computer first. Okay, here we are on the circuit diagram. Let's just get an overall look at it here. Okay. So, what I'm really interested in now are any capacitors in the IF string, paper, like larger wax paper capacitors that I can get rid of. You know, I think this, no, that's not one. Here's one, 0.1 microfarad. So, but before really hunkering down on these capacitors, which are connected into all the circuits here, I really want to understand what is going on down here. This is a common technique for obtaining bias voltages in a radio, and I sort of had a notion of how this works, but I really wanted to hammer it out and really sort it out. It's a bit of a confusing schematic the way it's drawn, so I've made some hand sketches to review this stuff and make it seem a little more sensible to me anyway, because this is all about me understanding this. Believe me, and don't take this the wrong way, I'm not trying to explain it to you as a viewer. I'm trying to explain this to myself, so I have a really good grip, so I fully understand what's going on up in these circuits, what these resistors are for that are all through here, some of these capacitors, all that stuff. And I think it all kind of starts down here. So something that's worth noticing is the power supply, okay, produces a positive voltage out of the filament basically, and a negative voltage in many radios is directed, this part here, this center tap is directed straight to the chassis, but not in this radio. In this radio it reaches the chassis through two resistors here or through two resistors here to get to the chassis. And I think that's a curious thing, and as I said before, I know generally this is to produce a negative voltage, but how it does it exactly was going a little bit over my head until now. Now I've made some diagrams that are going to help analyze this. So let's take a look at my diagrams here. Okay, I need to warn you, as much as I criticize the drafting techniques used on the different schematics I look at, my own techniques are pretty crappy too, so can you see that? Okay, let me just grab a pointer here. Okay, forgetting all this stuff. This represents the B+ power supply here. I've got the battery drawn backwards, so don't get hung up on that. The positive is up here. This would be going to a plate, which I didn't bother drawing. This square box represents the entire radio of tubes sitting here. This represents two of the resistors that we saw in the circuit diagram. These guys down here, or these guys. So what becomes apparent when you look at this, by the way, this guy looks like a very upset cat, doesn't it? I just put a couple of ears on it, but this is the cathode coming out here. The cathode, if you look on the regular schematic, is returned solidly to the chassis. So that's what I've shown here, solidly to the chassis. And the bottom of these voltage divider resistors is also connected to the chassis, so these are really connected together. So at that point you can see there's a circulation of current this way. Well, I better show it the other way. because we usually think of current as flowing from the cathode to the plate. So let's think of it that way. So unfortunately, I've got all my arrows drawn backwards here. I went to a college which taught conventional current flow. So if you wanted to talk about electrons, you had to say, I'm talking about electron flow at this point, or confusion would abound in the school I went to. It's one of the few schools still teaching current flowing from positive to negative. So that's where I got all these lines from. School, a long time ago. Funny any of it remains in my head at all. So we're coming down through these resistors in order to get through the tube. You can't get tube current without it passing through these resistors. So that's where the current flow in these resistors come from. It's just the tube quiescent current going around like this. So these are very much like cathode resistors. You could think of this as a cathode resistor, but they've split it into two, and then they take a lead off of here and hook it up to the grid. That gives the grid a negative voltage relative to the cathode, which is the whole trick here, is to make the grid negative to the cathode by some number of volts controlled by this. So if we look at my next diagram, which is really scary, so I tried to draw more of the radio in here. So I apologize again. I can never again criticize someone else's schematic diagram here, that's for sure. So here's the resistors we're curious about, the voltage divider resistors. Here's the negative bus from the power supply, positive going to plates. I didn't draw them all, why bother, but that's where this goes, to the plates. So you have current flowing through that circuit I showed you, coming up through here, okay, producing a voltage drop at this point, or producing a voltage relative to the chassis based on the voltage drop here. Now you have a slightly negative voltage coming up here, and look where it goes. This is kind of wild. It goes through I think this is a large resistor. This is the tone control. It goes right into the tone control, out the slider, and up to the grid, which kind of freaks me out, because I would think moving this tone control is going to change the DC potential up here. If you notice, the DC voltage here is trapped by these capacitors. It can't go anywhere but up through here. But the fact is, there's little or no current flow in a grid circuit. And no current flow means no voltage drop, means no variation in the no voltage drop in here as you move this control up and down. So that's my thinking. It's kind of like you're applying a static potential to this grid. Yes, there is a tiny amount of grid current. I'm just ignoring that factor. So that's what's going on here. Oddly enough, the grid is biased through the tone control. That's what I got out of it anyway. And you know, hey, big warning here. I may not have this right. So we look at these two. Maybe just look at the ratio here. 20. I'm pretty sure this is 20 ohms to 200 ohms. So it's a 1 to 10. So you get about a tenth of the available voltage between here and here being picked off and sent to the grid. This one's different. This is 10,000, 20,000. So you're getting about a third of the available voltage here being picked off and transmitted where? First goes through this, what I assume is a large resistor. I have trouble reading this on the schematic. A large resistor, I would think. And you get up on this side, you have a fairly high impedance circuit here. Through another resistor to a grid. Grid. Watch out. Resistor. Resistor grid. So this is all going to all the grids of these other tubes, including the I tube. That's the I tube. Can you tell from my artistry that that's an I tube? So this is controlling the set point, careful what I say here, of the bias of these tubes. But there's another force pushing the voltage around on these tubes, and that's the AVC voltage. I've shown it coming in here. I haven't shown where it's coming from, but it's coming out of the detector tube. It's pushed into here with a fair bit of strength. This is a low impedance. There's a fair bit of oomph behind this. So it also, again, because there's little or no current flowing in these grid circuits, whatever voltage is here, even though this is a big resistor, shows up over here. So you have a combination of the fixed bias and this AVC bias added in. It's either added in, or I think what really happens is this sets a floor, a minimum grid bias. Let's just for fun, let's say it's minus 2 volts. I don't know why you would pick that, but let's say it's minus 2 volts, and then the AVC will drive it more negative from there. So given no AVC, you still have a set grid voltage here. I think that's what's going on here. I'm not so sure of that. So of course there's capacitors. I haven't shown them here and there in this circuit and other related circuits up in here to like for instance here, block any DC from getting through here. In fact, you have a bit of DC on this side from this, and a little DC on this side from I don't know what I'm talking about. I'm talking too much. So that's how I think it works. So the primary idea is, again, I'm trying to get this locked into my head this time. I've journeyed into this area a number of times in the past, and I want to lock it in this time. So the whole deal is you're just returning all the tube plate currents through these resistors to get back to the power supply, and thereby utilizing the voltage drops, the ratio, to produce bias voltages. They have two sets because there's two quite different things going on, I guess, with the front end tubes and the last tube. The resistors here are dramatically different in value. Ooh. There's an ugly diagram. Where'd it go? So the resistors here are dramatically different values. Well, that suggests to me you put a smaller resistors in a voltage divider because you're going to take off a fair bit of current. So you want this current to be relatively small compared to the current going through here. So as you pull current out of here, you don't disturb the voltage at this point too much. That's the idea there. So you can think this is probably feeding into a low impedance. That's a great big resistor there. So I don't know what I'm talking about. But there's definitely a difference between this and this. A large difference. So maybe it'll come clearer as we go. Hopefully that was clear enough that I can continue here in some kind of brainful way. Okay. And what are we going to do? So we're going to go after this capacitor here. Okay, so this red one here, we'll get rid of this guy too. And this is probably part of more the front end of the radio, I'm not sure. This great big one, and there's one hidden back here I really hadn't noticed before. These two are going to go. That's only three. That's 3, 4. 4 capacitors. So I'll identify each one of them as I remove them. Well, four capacitors. Let's go back to the circuit diagram here. Okay, so I think there's 4 paper capacitors in this circuit here. So I've done this one. That's a picofarad. That looks like 0.01 right here. So grounding out the bottom of the IF coil. Maybe they're doing the same. Yeah, doing the same thing here. So it's hard for me to see. Well, here, let's zoom in here. Zoom in, Jim. So, well, that really makes it clear. 400 volts. I can't read this, but this one I think I can read. Looks like that looks like 0.10. That doesn't make sense. It'd be 0.0 something. I don't know. Can't read it. It'll be easy to find these because they're coming right off the pins. Probably. Now I'll take that back. No reason to think they're right up tight to these coils. They're in there somewhere. So this one clearly, it's a fairly large one, 0.1. Goes to the chassis, and what's it doing? Okay, so we have the AVC voltage developed back here. It's presented through here. AVC voltage low impedance here across this resistor. That looks like 2.2 megohms to me. On this side we now have high impedance, and that's where this capacitor is. So this large capacitor in a high impedance circuit, this is really trying to quiet everything down here. It's really trying to, I see it's right off the secondary too. This is the incoming here from the divider. It's going through a large resistor here too. I think that says 10 meg, would you believe it? Is that what that says? This means there's a very small capacity, small bucket here to put electrons in. It doesn't take many electrons in this little bucket here to change its potential. There it is on the grid right there. So that's probably that big one. If this big capacitor, if this wasn't working well, then the grid could start changing potential, and if you were to leak a bit of the signal from back here onto here, it wouldn't take much before you've got some kind of feedback loop. Now, do you remember, I don't think I mentioned it, when you tune this radio into a station, a heterodyne tone shows up. Very weak, but I heard it. What I'm concluding about these heterodyne tones that show up with every signal you tune in a radio is it's indicating that some of the IF output is making it back into the start, or maybe back into the middle here to go through again, producing a alternate signal to heterodyne with the intended signal. So you have sort of a free oscillating, say 455 or 460 in this case, 460, freely oscillating. As you tune the radio through a station, the station's converted signal approaches 460. So let's say it's at 465, let's say. So that's 5 kilohertz away from here. Now you have two signals in here. You have the 465, not quite properly tuned radio signal, and you have the 460 resonant thing going on in here that's getting back, it's coming back out. That's my thinking. And this is what will kill the coming back out. Well, it can still come out, it just can't get back in because it can't get past this huge capacitor on this high impedance circuit. So what you're looking at here is an engineering designed to kill any signal on this wire here, on this part of the wire. When we get up here, another resistor is added into it. Where'd we go? I got lost. And the lost puppy here. Where'd we go? There we are. Yeah. So this, look at 1 meg. So you're killing this part of the wire with a capacitor, and then beyond here, you're now into another sort of higher impedance area, if you like. I think if you didn't put this here, you would kill the signal entirely on this grid. So the signal's coming through here. So you're trying to kill them here. If you kill all the signals here, you won't have any remnant signals working their way up through here. So no remnant signals, you can inject the one you intend, which is the antenna signal here. You intend to get it into here. So these are like isolating resistors, you can call them that. I think that's a proper word for it. So a little section in here that's isolated with a huge hole cut in the bucket here with this capacitor, so everything falls through, so all the signal disappears. Oh, that's my theory. Now why? So over here, hey, so this capacitor is quieting the bucket over here, but it's not quieting it over here. So come down, we go through another large resistor, pretty sure. Looks like, I don't know, 4.7 meg, could it be? Half watt. Come down through here, get on the other side, there's the quieter, down here, quieting any alternating signal, any signal coming out of any of this anywhere at all. It's all eaten up, falls through this hole basically. There's a hole in this pipe, in this bucket, and signal falls through it. DC doesn't fall through though. So the DC is all that's left, and that's all you want on this. This is the tuning eye. All you want is just the Avc voltage sitting here. You don't want signal here at all. But we're not really concerned about this yet. We really just want to, I enjoy explaining this stuff to myself. That's what I'm doing here. I'm feeling pretty certain now about how all this works. I've probably got some misunderstandings here, but they aren't serious enough in this area to make me do something stupid. Oh, well, we'll see about that. Okay, let's take a close look here. Okay, grounded on that end. And the other end, looks like the terminal coming off the IF transformer there. Pretty busy in there. Maybe if I can get a little more light on it. Now, okay, so there's that brown dog bone resistor, this big one here. It's also connected to that same terminal. And then there's a red wire. Goodness knows where that goes. I know it's lost. That's probably it down there. Yikes, going somewhere. So we got enough here to identify this thing yet? It's probably a 0.01 connected to a large dog bone resistor from what looks like a terminal on the IF. This would be the second IF. Second IF. Okay. Second IF. Well, is that it right there? It's also connected. This is very difficult to trace because it's shown like this on the schematic, but these, you don't know how long these wires really are. There's the resistor. So I saw a wire, a resistor, and a capacitor on a terminal of the second IF. Is there anything else like that? Is there any capacitor on here? Resistor. Ooh, we gotta go all the way up here, all the way down. Yeah, but I put that one in there. I know that's not the red one I'm looking at. I've already changed that one. No capacitor on that terminal, and these two, no capacitors up here. So this has to be it. This has to be the red one. It sure looks like 0.10, but it's got to be 0.05 or 0.01. Maybe 0.05. That's got to be it though. So now what happens if this guy's not working well? Then you end up with some of the output. Let me put it this way. Again, this is like opening a hole in the bucket and draining everything out at this point into the chassis. So everything coming out of this tube ends up pressurizing this coil and nothing else, which is what you want. You want all the pressure here is going to be transmitted further in, or transformed further into the radio. If you don't succeed in knocking everything out, then you're going to get some signal continuing down this way. Now look where it's heading from here. It's heading into the eye here. Ooh, who knows what would happen there. You get signal in here, which would, I don't know. Doesn't sound like a good thing to me. Hey, yeah. Likewise with this one. There must be another one of these on the other one. I should go after both these. So I think this is the red one. Where is this one? Doing the same kind of job. Let's go find this one in the radio, and then I can change both of these. That might be a good first step. So this guy, just off the other IF transformer. Okay, let's go back. Okay, off the other IF transformer. That's the one we were looking at. The first IF transformer is right there. So we're looking for a capacitor off a terminal that goes to the ground. Wow, isn't that? That's got to be it. Right there. That molded one also changed 0.05. And I'll bet you this one's a 0.05 also. We're not going to be able to read it until I take it out. So those two, and you know, when you look at them now, in the way they're positioned in the radio, they're really quite similar in their physical position. Now this big fat guy, we'll get to him in a minute. There's that cooked up resistor, which I'm not too panicky. Now what's this capacitor doing here? It's doing something, I don't know. We'll catch up with him eventually. Okay, so those two are the two. Good. Figured that out. Great. Okay, I'm going to get in there and change those. Okay, so let's just take a look at this resistor here. This is the brown floater that's connected to this capacitor I'm about to change. That's why this has come up as a topic. So when I look at the rating here, I read 15K. At 15K, let's just go a little bigger here. It's over here now. Is that 15000 or 25000? I think it's 15. I think it's 15K. So 15K would be something like brown, green, and then purple or something like that. Body and dot. So we have brown body, green dot, and then something, whatever it is. Okay, let's go take a look at what's actually in the radio and what it measures at. Okay, so I have some leads clipped across the capacitor. Yes, or the resistor. It's still in the circuit. And here's the reading I get. 24K. 24K. Now, if it's in the circuit and there's problems with measuring it in the circuit, the reading can only be knocked lower. It can't be knocked higher. So that resistor is at least this amount. At least this amount. And if we look at the resistor itself, maybe just a wee bit more light on it. It's this big brown guy here. Brown. Body M dot. Well, it's clearly a brown body. The end, which you can't see in the camera, I tell you it's green. So it's 1, 5. I can't see the dot. It's on the other side of the resistor, but boy, that's on its way to being a 15 by rating, but by measurement, a 25. Now that's way off. 25 is way off. This is slightly browned in here too. So, you know, who knows? Is this a replacement? Probably, because the lead is floating down here. Junk box replacement, 15K, turned into 25. Does it really matter? I think that's just too big of a change. That's way too big of a change. So he's coming out too. So we're going to put the capacitor in and let's put a new 15K high wattage resistor there. So I cut out that resistor. Here it is here, and then I thought, oh, let's look for the you know, body and dot. Let's look at the dot. I turned it over, and oh my gosh! So this one has heated up enough that the shell, the paint on it, is coming off. And as for the dot, yeah, I don't see any dot. Oh, maybe that's a yellow right in there. Yeah, there's the dot. I can see it better with my eyes, and I think it's a yellow dot that's turned brown. So, so that would be, well, I think it's 15K. Supposedly, measuring is 23. Whoops. Okay, I'm gonna tack one end here. Really tacking it, I'm soldering it. Another one of these chassis jobs here. may as well do this big one at the same time. May as well. It just barely fits in the radio. That's the spot. Okay, so I don't forget, I'm going to put a clip right on it here. Just marking the spot. I'll take this guy, he looks pretty good. We will find out though. 0.05. Now that big one that I cut out, what is it? 0.25. Uh-oh, didn't I say I'm running out of those guys? Okay, I got another resistor that may not be in good shape. A little hard to see in the long shot. It's right here. I'll switch cameras here, we'll get a little better look at it. Still not very good. It's this one here. This brown guy. Notice it's body end dot, brown. The end is green, I'm pretty sure, and the dot is green. So I make that out to be 1 million. So here's what it tests as. It tests a bit higher than that. Why is this jumping around? Is that a false measurement? As low as 290. Maybe I picked the bad leads here again, maybe. Ah. Doesn't get any lower than, well, 250. Well, that's 2.5 million. Okay, I don't know why it jumps around like this. Crazy meter. But in any case, I'm pretty sure, regardless of the wonky meter reading there, that resistor's gone high. That resistor is the feed to the plate of the magic eye, the dead magic eye. The magic eye that heats, but doesn't show us anything more than that. So I'm willing to bet better change this to a 1 megohm, proper 1 megohm resistor. Better do it now while we have a chance. Okay, just on looking a little closer at the resistor there, it's brown, black, green. That's 1 million. I've got its replacement right here. And one more thing, when I look closely at the resistor, which I don't think we can do with this camera, you just have to take my word for it right now. So the resistor is up here. This lead is tacked on. This is a replacement resistor, I'm pretty sure. Funny, I'm going down the same path as the last guy. Maybe that's not so surprising. That's a pretty big connection here. Go. Okay, let's attach this to the correct terminal. Okay. There we go. One more. Just have this resistor up here to connect. Stiff, stiff, stiff wires. Went wrong up here. I just didn't leave the heat on long enough, I guess. Not for sure. I saw the whole thing move. That's not the whole thing. Let's see. Floating down here still. Okay, that is a load of capacitors. Still got this guy. I haven't identified him. I want to identify this one next. What's he hooked up to there? He's hooked up to a resistor and a wire. There's a wire in behind here. And the wire. Just 1 second here. The reason I knew I easily identify this resistor as being involved with the magic eye, by the way, this is the plate, there's a resistor in the plate circuit, is this green wire. If you follow it, it goes down into that bundle. See the friction tape around it? And then they go out a hole. This is what the magic eye wires often look like, a bundle coming in together, and then they splay out into the radio. As if the magic eye was an afterthought, which it kinda is. So that's how I was able to. And then if you look at the tube pin that the resistor is connected to, there's no pin inside the tube. So that's a spare socket, or spare pin rather. And that's why they utilize it to make that connection. Did I get that good? Yeah. Okay, back to what we're trying to do. Identify this beat up capacitor here. So here's a resistor right here. You can certainly see the colors. Body and dot would be yellow. Looks like green. Body yellow, body. So 47. 47 megohms. That doesn't seem right. You know what it's connected to? It's connected right to the terminal on the back here. This thing here. It's connected right to it. It's connected to the middle one. And then it's going from here straight to the IF. The second IF. So look at under the second IF, look for a connection that comes out here and has a resistor on it. Has this other resistor. Two resistors on it, one to ground. Okay, two resistors, one to ground. One resistor goes to the capacitor. Wow, I keep all that straight in my head. That's cool. Let's go see. Okay, so we want to look. Whoops, we want to look at the second IF here. This is the thing on the back. So I come back here. Oh yeah, this goes all over the place. So here's a 22K resistor going to ground. That's one of them. That's the one. Just looking back, yes, it's 22K for sure. Going this way, this must be the resistor where, or this one. Okay, so this resistor goes to the magic eye again. It's probably, it goes to the grid, so it's probably a really big resistor here. I can't really read that. Or is it this one? This is R, I'm sure this says RB, and this is RG. Resistor, no, that's got to be R6, and that's got to be R8. That's what that's got to be. So half watt, this looks like 2.5 meg. This looks like 2 something meg. And this one, I don't know. Okay, so off the wire in question, there are 3 resistors according to this. 3 resistors. Well, if one's going to the magic eye, I can probably figure that out the same way I figured out the plate. So is this the one? Is the one I'm looking at going to the magic eye? It's the one I am looking at going to the magic eye. And what the heck am I looking at? I'm looking at this because I want to identify this. So, okay, lots and lots of wires all jammed in there. Let's see what we can sort out here. So, yeah. Ooh. Okay, so that's the wire right there. Yep, you know what? It goes right into this bundle. So there's a wire from this terminal going to the magic eye. Almost certainly the grid. Now, can we find this capacitor coming off that wire? So we are now looking at, is it, we are going through the resistor from the IF. Through the resistor from the IF. Yikes. Here we are. Right there. And I make that out again to be body end dot 47. Wow. I think that's green. That's a, hey, 47 meg. Could that really be 47 meg ohms? Well, let's read it. Let's take a measurement on it. Starting to work on the magic eye here without intending to, but let's do that. I'm supposed to be identifying a capacitor. Hey, that would be it there. I sure can't read that, but I bet you it's 0.01 MFD. So that's the capacitor. And the resistor is of passing interest here. So we'll read the resistor and go after the capacitor. Okay, let's read the resistance of that resistor. Again, testing it in circuit. It's not really the best way to do this, but in many cases you can figure out where you're at. So I'm using clip leads too, so I can get a little more stable reading. That's 5 meg ohms. 47, so it must be 4.7 meg ohms. I think that's, green, I think that's right. I think it's 4.7 meg ohms. I'm a wonky reading here. I'm sure it's from my meter. It's close. It's pretty close, eh? Don't you think? It doesn't want to read down there right now. So 4.7, 5.2, there's no difference there. So that resistor is okay. But we now know what the capacitor does. Or we know where it is. It's going to the chassis, so we'll know it once again. It's trying to quiet something. So we'll take it right out. 0.01. So tomorrow, the United States votes its way into a new level of dysfunction. I really don't think the election is going to calm anything down in the States. But we will see. We'll see what happens. Truth and justice. The pillars of democratic society. Truth and justice. Anytime a democratic society loses faith in truth and justice, it's over. It's over. The only way to get back is to elevate truth and justice. Truth, justice, and the American way. I never understood what the heck the American way was. Frankly, I don't think there is an American way. It's the same way everywhere. But that's what I used to hear all the time, especially on the TV show, the FBI. Truth, justice, and the American way. Whatever that is. The truth is capitalism is unregulated at the moment in certain parts of the world, and capitalism is, if it unregulated, will eat itself, and all of us with it. We'll all party on the boat as it sinks. Okay, it's that happy thought. I now have everything connected in here. Paper capacitors all gone from here. I'm leaving this one in right now. Pretty sure it's a front end sort of thing, or sort of sure. Where's it connected? Wait a minute. No, it's connected here. No, that's got to go too. Okay, another one on the hit parade. It's a 0.1. 0.1. 0.1 on the capacitor hit parade here. That's right up at the chassis, so I'm going to turn up my soldering iron a few degrees. Because even though I'm soldering it to a little wire tail there on the chassis, the chassis is going to suck the heat out of it as I'm putting it in with my soldering iron. The chassis is sucking it back out. Increase the rate at which I'm pushing heat into it, but you know, there's only so much in this soldering iron too. The chance of making a cold joint here is really, really high. Could easily make a big pool of solder here. Have it look like it's on the little wire tail, but I should have left a longer tail here, but I couldn't. So now I got the pool of solder covering the wire tail. So I can only hope it's gotten hot enough there. Okay, I think I got it. cold right away. Now the other end. Hey, we're almost ready to run this radio again. Ooh, that certainly sounds like a good idea. I made a mistake posting videos, and I did not post a video, which I thought I had, so I'm a day behind in my posting. I try to post these videos the same day I do them, but I don't always succeed in that for various reasons. One of them being I just forgot to click post on the video. Work it right off here if I'm not careful. There. Okay, let's solder that. Good show. I think at this point, I think we're done doing part changes here. Good. That's it. We are in business now. Okay, we got two capacitors worth testing here. The paper ones, I don't think we even need to test them. We know that they're going to be leaky to some degree, but this beauty here, this appears to be in great shape. What's it rated for? 600 volts. Yeah? Let's find out. Okay, watch the eye. 25 volts. Open right up. 150. 250. This capacitor is in great shape. 350. Yeah, I mean it's opening on 350. It says 600. Let's give it 450. Even like that. So there's absolutely nothing wrong with this capacitor. So replacing it will not have done much. Goodbye to that. How about this one now? Astron. This one, I'll bet you this one's not as good. 25, here we go. Open right up, 150. And not quite all the way. 250, bet you it doesn't open. Just a little wee bit. Okay, so it's not bad. Let's just go back to this other one. Where'd he go? Here on the floor. This one, which showed no leak. Let's measure its capacitance. It's supposed to be 0.05. Yeah. Okay, 0.05 could be on this scale. 0.0125. 0.05. Swing right there. Right near the 0.05 mark. Perfectly good capacitor. Put him back in my box. He's got more life. But the other one, no. Okay, so we got quite a few bits and pieces now out of this radio. Hey, what about this great big one? What about this great big one? Let's do this big one. 0.25. Now, my experience with these is big honking capacitors. There's just more places to leak. I mean, it's like, how big is your roof? The bigger your roof, the more likely it is to leak. $25. This shouldn't even tickle. That opened. But no, not going to make it at 150. This guy's rated at 400, I think. Yeah. So again, this isn't a terribly quantitative test. Part of what I'm doing in testing the capacitors and testing the radio and changing them one at a time or two at a time is to try to figure out the calibration of this thing a little bit. How bad is bad? And of course, there is no clear answer to that because it depends what you're doing with the capacitor. It really, really does. Okay, I think we're ready to turn them on. Okay, first a little bit of a cleanup here. Make sure we got nothing funny happening. Okay, we no longer have the SDR connected in at this point. And volume down. Okay, for sure, dim bulbs are going to be important here. Cardboard box out of there. Get the kindling off your bench. That's what I'm doing. Okay. So I made lots of changes here. There is a potential for something bad to happen. So restricting. Here we go. Oh, perfect. Perfecto. Just give it a moment. That all looks good. Full power. Volume up. AM band, no antenna. It's kind of a bogusy test. Oh, well, it's working. Let's put an antenna. Now, there's a good chance the heterodyne tone will no longer be there. We will see. Okay, so we're on the loop antenna.
At a price in line that you agree to, or he'll buy it. Total service guarantee in writing. David Rose, they were nearing retirement and felt that it was time to downsize. Their home was in original condition. They weren't sure if they should spend a lot of money renovating the home or if they should sell as is. Frank Leo and Associates for advice. They were advised it could be done to maximize dollars without having to invest time and money into rentals. In less than 2 weeks, the property was sold as is for close to their asking price, and they can now retire. Frankly,
good for them. Bravo. Well, wow. Okay, so that sounded even better to my ear. Of course, I'm a little optimistic about it sounding better, so nothing scientific about that. But what are we left with now? We're not left with too much in this radio. Got this big resistor to check out. Got a paper capacitor here. The rest are gone. We got a resistor down in there that appears overheated. Another high wattage one. I think we're really close to redoing the alignment. I don't know, are there any other parts to change? I don't think so. So I think it's a question of redoing the alignment at this point, and finishing it up, doing the front end alignment. Then we're looking at tuning some of these buttons, maybe. Ah, wow. We're in really good shape. Of course, the alignment on this radio is involved because there's 5 bands. So there's five Probably 5. There's probably 5. Well, that's it for today. Thanks so much for watching, and this radio's coming along great. Fantastic. See you tomorrow.